The broadcast is now starting. All attendees are in listen-only mode.
Hello everyone, and welcome to the webinar. This is Sydney speaking, and what we'll be doing today in today's webinar is we'll be going through SolidCAM 2014 Service Pack 2, and this is actually a continuation to what we had done last week. There are some points I may touch again on that we did last week, but there are some basically I'll be going through options that I'm almost certain that everyone will really use. These particular options I'm going to show you today a lot because they're they're options that are often used. This will come into your every single day daily programming options that you normally use all the time. So without talking too much, giving too much of an introduction, let's actually get into the webinar itself. But before I start the webinar, I'd like to point out one thing on our website. If I were to look on our website now, you'll see that we have, excuse me, that we have on our website, if we go down a little bit, we have a PDF file of what's new in SolidCAM 2014. This can be downloaded, and if I were to open up where I download it over here, the simple PDF file, it has approximately 80 or so pages, and it has every single new option that's inside SolidCAM 2014 SP2. All of the options that are in there are inside this PDF, and this could be very helpful for you for future references. This, as I said, is located on our website itself. Taking a look down here on the home page, what's new, SolidCAM 2014. Now, besides that, we also have on the professor page, we have also what's new in SolidCAM 2014. And there I have a series of different recordings showing some of the main aspects of what we have inside SolidCAM 2014. And you can see it's broken up into different segments over here. For example, if I go into the geometry segment, you'll see that I have about 6 different recordings just on that area itself. And of course, just like any webinar I've done, all of my webinars, previous webinars as well, are on our websites. If you go into webinar recordings, you can see the last 4 webinars that were done, as well as what's new in SolidCAM 2014. All of those webinars are on this site as well. Okay, so let's go inside the webinar itself, and of course there'll be time for questions at the end. If you have questions, all you have to do is click on raise hand and write down your question in the question area. And don't forget, when you finish writing down the question, don't forget, very important, to click on the send button. If you don't click on the send button, I will not see the questions. Okay. Sorry, my fault. I just realized my screen was not turned on. I'll just mention it one more time again. As far as our website goes, if I were to go into our website, you can see on our homepage, there we go, now everyone can see it, my mistake. You can go onto our homepage and you can download the What's New in SolidCAM 2014. This is a PDF file that has about 80 pictures or so, 80 different pages or so of all the options that we have inside SolidCAM 2014, as well as the professor recordings. We have what's new in 2014 over here, broken up into different segments. All this on our homepage itself. Okay, let's start off with the first part that we have on our screen. And this particular part, I'm not going to program the whole thing. Actually, everything is programmed around. It's already programmed for me over here. You can see it's actually sitting, working indexial on this part itself. Everything is all programmed out really nice. I'll just run a quick simulation on this using Solid Verify, And you can see everything over here is machined out exactly the way I wanted it to. All the sides, no problem at all. Now, what I'd like to do now is I'd like to actually go in here and add a chamfer on the edges itself. Now, adding a chamfer, I've talked about chamfer recognition before, but I want to go over it again because, again, this is a very, very important feature that we've added, and I just want to make this clear. And there are certain points I'm also going to point out over here that I haven't pointed out in previous webinars. Okay, so like I said, I want to create chamfers on the edges over here. So to do that today, all I have to do is go into recognition, and we have chamfer recognition. And in chamfer recognition, when we create a geometry, we have two options to create a geometry, either by picking a solid body or by picking individual faces. In this particular case right now, I'm going to take the entire solid body, and I have a minimum diameter filter of 10 millimeters. So anything that's less than 10 millimeters in diameter will not be chosen and will not do a chamfer on those edges over there. Okay, let's actually click on the part itself. It's being recognized now, and as you can see, every single face was found that needs every single edge was found that needs to have a chamfer put on it. Okay, I'll be choosing my tool. In this particular case, I'll be choosing my chamfer mill. 6 millimeter in chamfer diameter is fine for me in this particular case. And if I go into my levels, the only thing I have to do over here is just tell it what's the depth that I want on my sharp edges. I'll put it at 0.5 millimeters. And if I go into technology, we have our cutting diameter. Cutting diameter, what's the actual diameter of the tool that I want to cut with? Let's put it at 2 millimeters. And the important thing over here, which is actually that we've added over here, is this little option over here called safety offset. This will make sure that my tool will not go into these walls over here, because it's working on this edge, but it has to make sure that it stays clear of this wall over here. Same thing over here as well. That's what the safety offset does. Now, let's run our simulation on this. And as you can see, it's doing exactly what I wanted it to do. Doing those edges working on those edges over there, that over there, that one around there, this one over here, and then it's going down to the whole inside because it's larger than 10 millimeters, so it's doing that as well. And then it goes down to the next level. You notice it works from the top down. Okay, we will be adding an option later on if you wanted to work from the bottom up, giving you that choice. But right now it works from the top down. Finishing off my chamfer over here, you can see that all of the edges were done, and the safety distance that I was talking about from the walls, you can see that actually over here, that it did not get close to the walls. And this was done simply in one simple operation. Now, what I'd like to do, however, I'd like to do the same on this side over here as well. So, sorry, on this side over here as well. So what I'm going to do is do save and copy. And this time I'm going to choose a different mat. I worked on this part in different positions. I'm going to choose position 2. Position 2 is on this side over here. And what I'd like to do is put a chamfer on this face over here. So I'll go into here, and this time instead of using solid body, I'm going to use the option of face. Now when I click on face, all I have to do is choose the face I want to work on. I'll click on this face over here, and you can see it was put in over there. That's all I want to choose at this moment. I'm going to leave everything else the way it is. Same tool, same levels, same cutting diameter, save and calculate, run my simulation, And you can see it does exactly what I wanted to do, worked on that edge. And then I can go on for every single edge I want to do. If I want to do it again, save and calculate, save and copy, do this time on Mac 1 position 3, being the flip side on this side over here. Again, doing the exact same thing. Face, click on this face over here. Direct save and calculate immediately, and you can see I've done it on this side as well. And I can go basically from every single face that I want to work on. So I don't have to do the entire body. I can just pick specific faces as well. Okay, now let me load the next part. Let me close this one. And let's see, we'll go into SolidCAM, open, and we'll choose my next operation over here, the next part over here. Now, this part, we're doing some pocket operations, we'll be doing some profile pocket operations and some slotting operations, a slot operation, and even some drilling. But what I like to, the things I like to show you in here is, it starts off as follows. First of all, if we take a look at the part itself, we have these three pockets I'd like to point out. This one over here, and this one over here. The depth of the pockets go to different levels. Okay, so they're not on the same height. Now, in previously, if you do a regular pocket operation, you would have to do a separate one for each one of them. Now, so let's start actually the pocket operation now. And I'll start by creating my geometry. We'll choose this one over here, that one over there, and this one over here. We have our three geometries as looking at it from the top. No problem. I'll choose my tool. I'll choose 10 millimeter end mill right now. Now let's go into my levels. Now, in our previous pocket operations in 2013, you were not able to do these three pockets in the same operation that had different depths, because we always worked with the option of constant depth. However, in 2014, we've added, besides constant depth, we've added an option called variable. By variable, we actually have now the option of variable depths. If I want my first chain, just click in that surface. It happens to be 25, that's fine. My second chain, my second pocket, up until this surface over here. You'll note it got its value of 15 millimeters as well from here. And my third chain up until that surface over there. So we have our three different depths. Excellent. Simple, no problem. One operation, three different depths on all pockets. Okay. Now, before I do my calculation, I actually want to go into my technology and point out another feature that we've added here. We've added inside the pocket operation the option of going into geometry and actually offsetting the geometry itself, besides the actual wall and island offset that we've had previously. If I were to put this in my top view, go into geometry, and this is actually very helpful. Specifically, let's say you have a besides the solid that you got a blueprint with the solid, and on the solid it gave you an actual measurement that was gave you a tolerance that was in a negative or in a positive direction only. So you wanted to have a positive or negative offset for those pockets as well. So what we can do is, instead of starting to work with the offset that we had before, the regular offsets over here, wall offsets, we can do that now inside our geometry and actually move our geometry. We have this in our profile operation, but we have this now in our pocket operation as well. Now, for example, if I were to say I want my first chain over here, and you see I have chain 1, I want to give it an offset of 1 millimeter, you'll note that it moved in 1 millimeter. Now, if I wanted to do this the same for every single one of the pockets, all I have to do is click on Apply to All, and then they're all changed as well. Now, if I don't want them all, let's say, for example, chain number 2, I want in the opposite direction, no problem. Chain 2, -1, and you can see it's going in the opposite direction. If I want 3 to be exactly the way it is, back to 0, no problem. Chain 3, 0. And we're all set. Different setups, different offsets for each one of them. If I accept this, note also what happens on our page. On our page, we have actually a pencil over here on the side showing us that the geometry has been edited. The geometry has been edited. You can easily tell now that, okay, I want to make a change over here. Has it been edited? Has it not been edited? You can see over here it has been edited. If I go back into geometry and put in here, for example, 0 and apply to all, in other words, putting everything back to its original state, the pencil is gone. Okay, let's just do a quick save and calculate. Run my simulation. I'll use the wireframe this time so you can see it actually from the side, and I'll have it see-through. You'll see that the tool goes down. You can see that over here as well. And as it goes down, it does its first cut, next cut, that one over there, up until that surface. That's the depth of that particular pocket. Now let's continue as it goes to the next pocket. This one, that step, up until this surface itself, because that's the depth of this pocket. It's going to finish this, and now it's going to go to its last pocket over here, finishing off to the depth of that particular pocket over here. And that's the depth of this particular pocket, working on the levels of, excuse me, of variable depth. Okay, let's put this back at the shaded view. And what I'd like to do now is work on this slot over here. So we'll start a 2.5D slot operation. And we'll choose my geometry. Let's first start by choosing my geometry on the sketch that I have over here. I'll choose the sketched line that I have over here. No problem at all. I'll choose my tool. My tool in this particular case will be, again, I'll use the 10 millimeter end mill. And we have our levels. We can have our upper level from over here itself. Now, note, first of all, when I choose my levels, I can choose my levels either from upper level and then click over here and then click on OK, or I can click upper level over here the way it is right now. Without clicking on upper level, just click directly on the surface and it populates that window. Okay, we're set over there, but now let's go into technology. In our technology, we've also added modify to our slot operation as well. If I go into modify geometry, note, first of all, we're working on the center. That's fine. But let's say for some reason, I have to move my center over to the side in either direction, either this side or that side. So we've added the option of modify offset over here, just like we have in our profile operation. I'll set this at 1. Note that it worked over to the right hand side 1 millimeter. If I were to write -1, it will go in the opposite direction. And that's not a problem at all. Okay, now let's put this back at 0. Leave it exactly the way it is. And let's try a different geometry. Now, the geometry I'm going to pick this time is going to be a little different. We're going to click over here, and this time I'm going to choose this line over here as my geometry. Okay? Now the tool that I want to use right now is going to be an 8mm end mill. Okay? And actually what I want to do is I want to go down the middle of this slot over here. Now this is very helpful, specifically since this will allow me not to have to create a line in the middle, a sketch in the middle. Again, I have my levels, my technology. I'll use modify geometry, and I want to go half the distance to be exactly in the middle. So we have the option over here, modify offset. I'll say take half the selected offset, highlight this window, and then click on the other side of the slot itself, thereby taking half the distance between these two in the slot itself, between these two walls, putting it exactly in the middle. Of course, we have our depth, and our depth, again, I can flip the part around and just highlight this area and click on the bottom floor over there. Of course, we have our step downs, whatever step down I want to put in over here, not a problem at all. And of course, if I do save and calculate, simulate, you'll see that the tool will go down exactly in the middle of the part. Let me do exactly one step at a time. You can see the tool, top view, going and working exactly in the middle of the part, of that slot. Okay, now one more thing I like to do on this particular part. We have drilled holes over here that I have to deal with. Now, as I said, there are times you get the blueprint where the holes are not have to be moved over a bit because of tolerance purposes. So if I were to go into my 2.5D drilling operation, choose my geometry, the top of the surface over here. At this point, we have the center of each hole. I'll choose my tool. I'm going to choose a drill. Let's choose the drill diameter. If I click over here and click on the edge over here, we have a 6.8mm drill, as you can see over here. And we have our levels. My depth will be up until that point over there. Again, I did not have to click on the button. I could have gone directly over here. But now if I go into technology, excuse me, if I go back to geometry, you'll note that in geometry, we have an option here called Edit Geometry, Modify. If I go into Modify, you see the actual location of each hole that we have over here. If I want, I can take any one of these holes as shown over here. Let's take the first hole, and I can say, let's shift it in the X direction by 1mm, and in the Y direction by -3mm. You can see it's shifted exactly to where I want it. If it has to be -0.1 and -0.1 in the X and Y direction, I'd write the same thing over here as well. Same thing with 2, same thing with 3. Let's do 3 exactly. We'll do this at 0.1. And let me just zoom in so you can see exactly what's going, make it as close as possible. And shift Y also -0.3. And as you can see, everything is shifting over here accordingly. Just accept it, and we've moved our holes in the proper directions, exactly the way we want to have it. And of course, all you have to do then is just save and calculate, and now you have your holes drilled out exactly in the locations without having to make sketch points on the part itself. Everything was done exactly where it's supposed to be. Okay, now let's go to our next part. Now, in our next part, and you'll see it in a moment, you'll note that this particular part, very colorful. You can see we have different colored surfaces over here, and I'll explain that to you in a few moments. But before I explain that to you, let me actually go first into the profile operation I did around the part itself. Now, if I go into my profile operation itself, we have our geometry as shown over here around the part itself. Now, in this particular case, if I go into my technology, I used the option of clear offset to work my way from the outside in, as if I had that much more material from the outside, and then working my way in. Okay, using clear offset here, no problem at all. Now, if I were to run my simulation exactly the way it is right now, let's do this one step at a time without showing the tool. And I'm going to zoom into this area over here. You'll see that the tool goes down. We have our tool pass over here. Now, when it went in with an arc over here as shown. Now, when it gets back to that point and it has to start doing its clear offset, it goes in a linear motion to its next level. Same thing around over here itself. Again, another linear motion as shown, going directly into the material itself. And then at the last cut, it does the lead in and lead out for that particular wall. Okay, but in many cases, and many people, and myself also as well, I do not like to go directly into material. So what we've added over here now for the clear offset option is as follows. We have now adjacent passes connection. By adjacent passes connection is we just had adjacent passes over here. How do you connect between them? We had a default of linear which is the way I showed it to you right now. But we also have two more options. One is rounded, where it rounds out of one and then goes straight to the next one, but then rounds into the next one as well. Taking a look at the simulation itself, you'll see that it goes in with its first lead in with the arc. Now when it goes to the next level, it rounds off of this pass and then rounds itself into the next pass itself. The same thing as it gets down towards the bottom. Now, one more option we have besides that is use lead in and lead out. So every single time it works on a pass, it's going to do a lead in and lead out, whatever has been defined down here. Let's run the simulation itself, and you'll see that as the tool goes around, it does a lead in, but this time when it comes to this point over here, it's going to do a lead out. Then go to the next area, do another lead in, another lead out, and this way doing a lead in and lead out in every single one of those passes as shown over here. Okay, now next I'd like to work on these surfaces over here. In other words, these pocket operations over here. But I'd like to break it up and do different operations, different pocket operations. I want to use actually pocket recognition for this, but I only want to do specific surfaces on that particular pocket recognition. So what we have now is the option of choosing it by colors. Note I'm demonstrating it by putting two different colors inside the part itself, besides the original color that it has over here. Okay, so we'll start the option of recognition, pocket recognition. Now, when I choose my geometry, we have a filter here called color. If I choose the option of using that filter, I can go into define. Let's say I want to use this color over here. I can go into define and find that color over there. Now, for people like me, that's a little difficult because honestly, I'm a little bit colorblind. So it's very hard for me to tell the difference between this and this. I'm not sure exactly which one I should be picking. So if I click on cancel, we have one other option. We have something called pick from model. If I were to click from model, all I have to do is click on the model and it will automatically populate the right color over here. Look what happens over here when I click on this surface over here. You'll note that it automatically gave it the right color code for that particular surface. Now when I click on the part, it'll recognize only those surfaces over here. We have 1, 2, 3, 4 different surfaces. The fourth one over here, this one over here, this one over here, and this one on top over here. And that's it. It did not take any other surface, just those surfaces itself. I'll use the end mill I need to use. Let's use the 16 millimeter. I'll use this one over here. And actually, you know what? I'll use the 16 millimeter. He's correct. There's a reason why I made that. Okay, 16 millimeters. My level is exactly just like they were working in regular pocket recognition. Everything is fine. Since I do have open pockets here, I can use the options of open pockets if I want. Just let's do a quick save and calculate and run my simulation. And you'll see that we get the tool pass around the part itself, not touching any of the areas that I didn't want to work on. Okay, not working in here or here, working on all the rest of the areas over here. Everything was done fine. If I want to do it on Solid Verify, no problem as well. All of them are done exactly the way I want it to be done. Now I'd like to do another operation, but this time work on these surfaces over here. Save and copy, create a new geometry. This time in my color code, I'm going to pick for model this color over here. Again, it's been populated. Just click on the face on this part itself. And you can see all of these over here. Okay, those were chosen. Again, just choose the right tool that I need over here. And we have a level. Let's just do a quick save and calculate. Run my simulation. And you can see it's working only in those areas, touching no other area at all. Okay. Now I'd like to load one more part. What I'm actually going to do, however, this time is not going to start from SolidCAM. I'm going to actually start from SolidWorks. I'm going to start actually creating a project now. And we'll go into SolidCAM, new, milling. Everything's fine over here. Create my coordinate system. I'll click on the surface over here. Note it's in the corner over there. That's why I want it in this particular case. And we're basically all set at this point. And what I'd like to do is create my stock. My target has automatically been created. And you know that now that's been created already by the fact that next to target, we have a check mark over here. The same thing by define. You can see our coordinate system has been defined because it has a check mark next to it. Our stock does not have a check mark next to it, so this still has to be defined. Now, if I were to go into stock, in our box option, we have the relative to model, and we also have absolute coordinates. Now, let's go into absolute coordinates. And what we all know already from absolute coordinates is that it does not even look at the model itself at this point. What I have to do is just put in the actual measurement of of the actual stock itself. Now, for me to know what the actual stock size should be, I have to know the measurements of the part itself as well. So I have to go ahead and measure it. But in this particular, specifically in this case, it's not so easy for me to measure the part itself. I have to go out, find the points over there, then find the points over there. Not so easy. But we've added now an option inside SolidCAM 2014 that when working in absolute coordinates, I can tell it, you know what, take model dimensions. If I click on take model dimensions, you'll note that it'll automatically populate these coordinates values over here. And this is the actual size of the stock itself, as shown over here. just about 240 over here, just about 140 over here, minus 30 over here. Everything was put in. Of course, this is still open, so I can always make my changes. Okay, I could say, look, in the X plus direction, I want my stock to be based on my home position. Remember that? Based on my home position, I want it to be 242. Take a look at the top view. You can see now that it's out to here. In my X minus, I want it minus 2. Minus 2. And you can see that it's now minus 2 millimeters on the other side as well. But you have your exact measurements of your stock over here. And the same thing in Y and the same thing in Z. Now, let me go out of here for a moment. And let me actually not accept this part and restart again. This time, before I actually start the part, I'm going to go into SolidCAM settings. Now, in SolidCAM settings, if I go into stock definition, I can make my life a little easier here as well. I can say, instead of going into relative mode, I can say go into absolute coordinates for my box. And if I do that, we have the check mark over here that says take model dimensions. If I keep it clicked on take model dimensions, then it'll do that automatically when I open the field. Let's see exactly what happens. We'll close this. And we'll go into SolidCAM new milling. Accept that. We'll define our home position, our coordinate system over here. We'll accept that as well. And this time when I go into stock, you'll note that it automatically takes the value over here without me having to do anything. You know what? I can be even better than that. Let's go back out of here. Again, I'll start from the beginning. But this time in my settings, I'm going to make one more change. In my settings, what am I going to do? I'm going to do SolidCAM settings. And inside my CAM part, we have the option of automatic CAM part definition. In automatic CAM part definition, I'm just going to click on the option of definition of stock to be done automatically. I'll click that. And now I'll start my SolidCAM project again. Accept that over there. Create my coordinate system by clicking on that surface over there. Click on OK. And you'll note that my stock has already been created, and you can see that by the V mark, by the check mark over there. So I'll just accept that, and we're basically all set to go. One more thing I'd like to point out. Today, when you create a coordinate system in SolidCAM, we automatically create a SolidWorks coordinate system based on that point over there. As shown over here. Click on it. That is the actual coordinate system. Zoom in. You'll see it actually a little better. This is the actual coordinate system that is created inside SolidWorks again. What you can do with this is also very simple. It makes it also a lot easier to measure from your coordinate system to a different entity on the part itself without having to create a draw point over there to use to measure to. For example, if I want, I can go into my tools and take my measuring tool over here and say, okay, let's take this circle over here and this diameter over here and click on the coordinate system as shown over here. You'll automatically can see what the measurements are to that. You can see that what the delta in X is, what the delta in Y is, what the delta in Z is, and of course the diameter of the circle itself. And this was done easily because we have the coordinate system of SolidWorks automatically created over there, and I use that to help me find the measurement to my my machine coordinate system as well. Okay, that's basically the end of the webinar. Let me just go through, I see I have a question on the screen, and it goes into the chamfer recognition. Does chamfer recognition only work with faces that are perpendicular? If it's on a slight angle, it will pick up the edge of that as well. Okay? It will not work. One moment. Let me just open up the part again. It will not work on a corner that's completely perpendicular to that surface, however. Okay? It'll work on this surface, and if this surface it was a slight angle, it will work on that corner as well. Okay. To clear these corners, however, you would do that in your regular profile operation by rounding the corners itself. Or in this particular case, since it's a 5-axis machine, I'll just index it up to that surface over there, and then just do the chamfer operation on this surface over here. Okay. Thank you everyone for joining the webinar. Again, this webinar has been recorded and it will be available tomorrow on the website itself, as well as the parts that I've used here as well. So everyone have a great weekend and enjoy yourselves. Take care and see you at our next webinar.